Here we have a sample problem that gives us a chunk of information first. We are told that piebald spotting is a rare human disorder where the dominant allele interferes with pigment-producing cells. Thus, patches of skin and hair lack pigment. We're given a pedigree with 3 generations, and we're asked what is the probability that any offspring produced by individual 2-5 and 2-6 would have the piebald spotting trait. So we can figure this out pretty easily. We just have to do some analysis first. So we are being told we're looking for 2-5 and 2-6, which are going to be these 2 individuals right here, because this is generation 2, and then it's number 5 and 6. We are also told that this is a dominant trait. So the individuals in this pedigree who have the shaded shapes we know are displaying the dominant phenotype. That also means that the individuals who, the individuals who are not shaded in are recessive. So I'm going to indicate my alleles this way. Big B is going to give us piebald spotting. I'm using B because both P and S are impossible to differentiate between each other for lowercase and uppercase. And then little b is normal. Okay, so all of the individuals who are not shaded in here are homozygous recessive. So the way I'm going to analyze any pedigree is I'm going to start by filling in all of my homozygous recessives. This is going to look different depending on whether the trait I've been given is a dominant trait or a recessive trait. But in this case, I have a dominant trait, so the unshaded ones are giving me the recessive phenotype. And that gives me a bit of useful information right away. It tells me individual 2-6 is a homozygous recessive. She has the phenotype of little b, little b. What about individual 2-5 though? I know that he has to have a big B, but I don't automatically know what the second one is. Thankfully, this is where the pedigree becomes useful. We can see that his father, individual 1-1, is homozygous recessive. So he has to pass on the little b allele. So we know that individual 2-5 has to be big B, little b. We can make the same conclusion about his brother and sister as well. 2-3 has to be big B, little b, and so does 2-8. If you want to finish filling it out, we can also make the conclusion that 3-1 is big B, little b for the same reason. What about 1-2? Well, 1-2 has 2 children, 2-2 and 2-7, who are homozygous recessive. That means that she has to have a big B because she has the dominant phenotype, and she has to have the little b as well because she has to be able to pass on the little b allele. Okay, so now we know that 2-5 and 2-6, when they have children, the cross is big B, little b versus little b, little b. Now all we have to do is make a Punnett square. With our Punnett square, we see that half the children will be heterozygotes, half of them will be homozygous recessive. So what is the probability that the offspring will have piebald spotting? The probability is 0.50 because half of them would have piebald spotting.